Okay, this is the form that's called Representing Quadratic Equations. This is the sheet that is due for homework on Thursday. And we did, I don't have it still done on this page right now, but in class we did this one here. And we went through the whole process of that one. And that was the one that was given in factored form. So before I go on to do another example problem, I want you to see that this bottom one is also in factored form. If you were completely to list this one out, it would look like this. Sorry, that should be a 4. So just recognizing that that form is the same as that form. They're both in factored form. So this is actually already in vertex form as well. So we can go ahead and write that over in the vertex form column. So there's a head start on those two. And then if you wanted to get to standard form for that one, you would multiply all this out, all this function out, and simplify it to get over to standard form. And then you can pick out the points that are most important from each of those graphs. I'm not going to do that full example because I want to show you different forms to use as an example. So we'll do this one, this top problem here. I'm going to be looking at this vertex form right here. This is the back side of that worksheet. It's in vertex form, so we are able to pull out our vertex. So our vertex is equal to, remember it's h, comma, k. I'll rewrite vertex form up here for you to have that. So it's ax minus h squared plus k. And that's why when we have it in vertex form, when we're pulling out that h value, it's always going to be opposite value. So for our example here, our vertex is +1, +3. You don't really have to write that positive there. You can just put 3. So 1, 3. And the other bit of information that we can get from this one is that a is equal to -3. So from our vertex, that means this value here tells us that we moved right 1. This value here tells us that we moved up 3. And this a value that we have here, the negative portion tells us that it faces down. And the fact that it's a 3, which is greater than 1, tells us that it is thinner than our parent function. So now we'd like to get it into all those other forms. I think right now I'm going to go ahead and graph what I do know about this, and really the only thing that I do know is my vertex. It's at the point 1, 3, so my vertex is right here. I'll go ahead and label that as 1, 3. Vertex. I do know that it's going to face down, and I know that it's thin, but I don't know exactly where that graph is going to lie. So I'm going to go ahead and get it into some other forms to be able to tell us more information. So from vertex form, we need to go to standard form. We can't get it into factored form until we get it into standard form. From standard form, we can get to either vertex form or factored form, but we've got to start at standard form. So to start there, I'm going to go ahead and change the color here so you can see this is a little different. I'm going to rewrite my function that I'm starting with. So remember, we are expanding all this out and simplifying it. So if I do that, that's the same thing as -3 times x minus 1 times x minus 1 plus 3. So I'm going to FOIL that binomial first. I'm going to carry the -3 down, but I'm going to FOIL that binomial. So I get x squared minus 1x minus another x, and then 1 times 1 is +1 plus 3. Combine like terms, gives us x squared minus 2x plus 1 plus 3. And then I need to distribute that -3 because our goal is to get this back into ax squared plus bx plus c. So that's going to be -3x squared plus 6x minus 3, and then plus 3 on the end here because that +3 just carries down. If I combine like terms on that, I get -3x squared plus 6x, and the -3 and the +3 cancel, giving me 0 there. So this is my standard form, -3x squared plus 6x plus c. In this case, c is equal to 0. So c is equal to 0. And the important part of that is c is our y-intercept. So we know that our y-intercept is at 0. So if I were to plot that on the graph, we know that it's going to cross the graph at y equals 0. I mean the y-axis at y equals 0. Okay. Now, let's take that factored form, that standard form, and change it to factored form. So I'm going to rewrite what I just came up with as my standard form equation up here. And we're just going to factor that right side as much as we can. And notice that there's not a c term here, so it's not a normal quadratic. What we can do for this one is just take the GCF out. And I have a common factor. I can factor out a -3 and an x. So f of x equals -3x is going to be my GCF. And if I factor that out, I get left x minus 2. So I can't factor that any further, but now we've got to decide what values of x make that function equal to 0. So what we're essentially doing, we're putting in a 0 for f of x, and we're solving for what values of x make that function equal to 0, which is also our x-intercepts. So I've got -3x equals 0, and x minus 2 equals 0, and I'm solving each of those equations. So for this, if I divide by -3, x is still just equal to 0. And for this one, if I add 2 to both sides, x equals +2. So I have an x-intercept of 0, which is already plotted there, because that happened to be my y-intercept as well, and a y-intercept of +2. One thing that I forgot to tell you back from our vertex form is we also know the axis of symmetry. I'm going to write that in here. Back when we had vertex form, this is my axis of symmetry, is x equals h. So in this case, x equals our h value, which is 1. And so I'm going to put that in as a dashed vertical line. And notice our vertex is always going to lie on that vertical line. So that kind of gives us a little bit more indication of what our graph looks like. For this specific example, it would be beneficial to have at least one more set of points to plot. So I'll do that down below. I'm going to do it down in here, but notice I have an x value. My vertex is at +1. I've got an x value of 0 and an x value of 2 plotted. So let me try something a little bit further away, maybe an x value of 4. So I'm going to try x equals to 4. And I'm going to plug that into any form of this equation that I want to use. I can use the standard form, the vertex form, or the factored form, whichever one is easiest to come up with. In this case, I'm going to use the standard form because I just think that that would be easier. So what I'm calculating here is f of 4. And I'm plugging that in for my x into my standard form of this line. And if I calculate what this is, that's -3 times 16, which is -48, plus 24. And this happens to be a really big value, but that's going to give me -24. So what that means is that's a point on my graph. It's 4, -24. And obviously that's not going to show up on my graph here, but if I were to plot that, it's going to be way down here somewhere. Like, imagine that graph goes down, and it also gets mirrored onto the other side of my equation, right, of my axis of symmetry over there. So I should have probably gone back and plotted a 3 for that, but for the sake of time, we'll go ahead and leave it as that. And then I'm just going to sketch what this graph looks like. Something like that. So that's another example, and that's the one where we started with vertex form, we moved to standard form, and then we moved to factored form.